Hello everyone, I am Professor Vaibhav Shah. Welcome to yet another lecture on engineering curves. Today, in lecture 25, we are going to learn how to draw an involute of a circle for winding of string, a longer string. In subsequent lectures, we'll be learning different types of involutes like involute of a square, involute of a pentagon, involute of a hexagon, and so on. If you like my content and teaching style, then do not forget to like and subscribe to show your love and support. And try to share it with your friends, which might help them to clear their concepts. Let us start with one of the problems. Problem 1. Draw involute of a circle of diameter 50 mm. Given string length is more than the circumference of circle, which is 165 mm. So here we are dealing with the special case in which our given length of the string is more than the required length. So now once again we have to draw involute of a circle like our previous method. Here the diameter of circle is 50 mm over which we have to draw our involute, and in this example, the novelty is the string length is already given, which is of 165 mm. And they are saying that this string length is more than the circumference of the circle. So let us first assume some parameters. So here we are also taking winding of the string. That means we'll be winding the string over the circle. Here the length of the string is greater than your circumferential length, or you can say 2 pi r. And in other words, you can say the string is given which is of a longer length. So here longest string is given. So now this is a special case in which your string length is more than your pi d. So first of all, let us understand what we are actually talking about. Why it is that our given string length is more. Why we are saying that again and again. So let us understand what is actual requirement of the string. So from previous examples, we have learned that we need to wound around the string around the circle, right? Now, if we want to completely wound around the string around the circle, that means the string will cover the complete surface of your circle. And the complete outer surface of the circle is nothing but the circumference of the circle. So that means if we want to use our string to cover your circle completely, we must require the string length of circumferential length of your circle, which means either you require pi d length or 2 pi r length, which is nothing but our required length of string. So let us first find out the required length of string. Like our previous example, required length of string is nothing but the circumferential length pi d, which is equal to pi into d. Diameter here it is given as 50. You have to substitute this 50. So we will be having 157.08 mm. So this is the actual length of the string which we require to completely cover this circle with the string. Now, in this example, we are given with the string already of 165 mm. So here we are having the string length of 165 mm. This is known as your given string length. This is given length of string, which is nothing but your 165 mm. So now we are having two lengths. One is 157.08, which is our required length. And now in example, it is given 165 mm length of string. So first of all, we must compare these both the strings. So as we can see, 165 is greater than your 157.08, which means that given length of string is longer than our required length. Our required length is 157. It is obvious that given length is 165. That means our given length of string here in this case is longer than your required length, right? So that means our example is of your longer string. So we'll be doing this example by our longer string method. So now let us see what we'll do is. So first of all, you have to draw circle of 50 mm diameter. So for that, let us draw one circle with 50 mm diameter, or you can say 25 mm as a radius. Next thing, what? We'll be dividing this circle as usual into 8 number of equal parts by 45 degrees set square. After that, we'll be drawing one string length. Now, there will be confusion. That sir, which string we have to take? We have to take either 157.08 or 165. And mind that in example, every student know the answer, but they are confused in which length they are using. So always remember, this is the circle and the circle's circumference is pi d. That means we always require the length of the string equal to pi d. But in examination, while we are dealing with either longer string or shorter string, so the case is very simple. You have to compare both the lengths. Now here we have compared both the lengths. So this is higher length. So that means obviously you have to draw the higher length first. You have to compare all the time in all the cases that whichever the length is higher length, you have to simply take that dimension on your rounder. You have to take that dimension on your scale. Sorry, you have to take that dimension on your scale and you have to simply draw this line tangent to this circle like this, which is the length of 165 mm, which is larger than this two. So this is larger of these two. So this is 165 and this is 157. So we have drawn 165, which is a larger length. Now we have drawn this length. After that, we will identify this end point as P. So this is your 165 mm, which is more than your pi d. You will be always drawing the larger length. After that, now we will locate pi d length on this line. So it is obvious that pi d length would be 157.08. So now on the same line, you have to indicate this pi d length by any point. So I have just pointed out here like red point. So you have to just mark a dark point on this line, which will denote your pi d distance on that line. Clear? So once again, we have drawn the largest of these two lengths. So from these two lengths, the largest length is 165. So first we have drawn this line of 165 mm length, which is more than pi d. And after that, you have to indicate length of pi d, which is 157.08 on this line. And you have to indicate this point by this red point. As I have indicated, you have to indicate this point on your drawing sheet. So this will denote you your point pi d distance away from your center. Now it is very easy. So here we'll give numbering pattern to this circle. So let us see. Now this starting point would be always your point 0. And now we are winding this string over this circle. That means when we start winding this string over this circle in anti-clockwise direction, first portion of string will get in contact with this circle here. So that means it will come in contact with this portion of this circle. That means this portion is known as point number 1 because it is first in contact with your circle. So this is point number 1. So this is 0, this is 1, 2, 3, 4, 5, 6, 7, and 8. Clear? Your string will first get in contact with this point 1 here. That means this point will be obviously a point 1. Because when we try to wind this string around this circle, so this point of string will come in contact with this first portion of this part. That means this is your point number 1. Now after that, let us divide this line into 8 number of equal parts. So once again, there would be confusion. You will ask, sir, which line we have to divide into 8 number of equal parts, 165 mm or pi d? So always remember, we are dealing with this circle, right? So we are dealing with the circumference of the circle in each case. So we have divided this circumference of the circle. That means we have to compulsory take the length of this line exactly equal to the circumference of the circle, which is nothing but the pi d. So we will be always dividing this length of pi d into 8 number of equal parts. So let us divide this length pi d into 8 number of equal parts. So this length would be nothing but starting from your point 0 till your point red point. So you have to divide this line into 8 number of equal parts. Let us divide this line into 8 number of equal parts. 1, 2, 3, 4, 5, 6, 7, and 8. After that, we will give numbering from this point. So this will be your 0.1, 2, 3, 4, 5, 6, 7, and 8. So let us give numbering. So 8. Now, as you can see, we are having additional string from your 8 to P, which is nothing but your longer string, because here we are having this string, which is a longer string. So this is the extra portion of your string, which is a longer string. For that, we are doing this example. So next step is very simple. We'll be drawing tangents from each of the point 1, 2, 3, 4. So let us draw tangent from each of the point like this. Right? Now, next step. So first step, we'll try to wind this string around this circle. So first portion of string will get in contact would be 0 till 1 point would get in contact with this circle portion of 0 to 1. So this 0 to 1 point would overlap over this circle. So now our remaining string would be 1 till point P. So you have to take on your rounder distance of 1 till P. You have to put your round at point 1 and you have to just mark this point here. You will be having this point as P1. So you have taken distance from 1 to P. Now, when you try to wind this string from 0 to 2, then string will overlap this portion of circle from 0 till 2 on this circle. So after that, we'll be having remaining string 2 till P, which will be string from 2 till P here. So take dimension from 2 till P on your rounder. Put your rounder at point 2 on this circle and try to mark this point somewhere here. You will be having this point P2, which is the distance of 2 to P. Now, similarly, from 3 point, we'll be taking the distance of 3 till P on our rounder. Put your rounder at point 3 and mark this point somewhere here. You will be having P3, which is distance from 3 to P. Once again, for point 4, so 4 till P on your rounder, put your rounder at 4 and try to cut this line. You will be having this point P4, 4 to P. Again, 5 to P on your rounder, put your rounder at 5 and try to cut this line. You will be having this point P5, P to 5 is your distance. Now put your rounder 6 till P, put your rounder at point 6 and try to locate this point as a P6 point. After that, put your rounder at point 7 till P dimension on your rounder. Put your rounder on the 7 point on this circle and try to mark this point. So you will be having this point as a P7, 7 to P distance. Now here put your rounder at point 8. Take the dimension of 8 till P and try to put your rounder at 8 and try to cut this line of 8 somewhere here. You will be having this point as P8. After that, point P. So if we try to put our rounder at point P, then the radius would be 0 and we'll be getting point P itself. That means you have to connect this point with this point of circle somewhere here. So we have to just simply connect this point with circle directly here. We'll be having point P somewhere on the circle. So now let us locate that point. And after locating all these points, you have to just simply connect point P1, P2, P3, P4, P5, 7, P8 and point P. Let us connect all these points and finally to the circle. So we'll be having this as a final point. So the difference was we are having one additional point along the direction of your point 8. Now let us see one more example for better understanding. Problem 2. An inelastic string of 150 mm long is wound round the circular disc for one complete revolution. The diameter of disc is 40 mm. Trace out the path of end point of string. So simple, when it is said that you have to trace out the path of end point of string, which is nothing but the involute of a circle or involute in short, because the definition of involute says that we are tracing out the path of end point of string. So for that you have to refer my very first lecture, Introduction to Engineering Curves, and then in that lecture you will get to know the definitions of various curves and the application and basic geometrical constructions. So now let us begin with this example. Once again we are assuming the data winding of string. length of string must be greater than your circumferential length 2 pi r, and here the string length would be longer string. So now let us begin. So first, let us first find out the required length and given length. So required length is nothing but your pi d, pi into d. Your diameter given as the diameter of disc is 40 mm. So the diameter is 40, so put 40 here. So you will be having 125.66 mm. But here the string length is already given. Inelastic string of 150 mm long is wound round. That means we are already having one string of 150 mm, which is a given length of string. So that means given length of string is equal to 150 mm. So we are having two string lengths, 150 mm and 125.66 mm. So now let us compare these two lengths. So 150 is obviously greater than 125.66, and 150 is what? Your given length of the string. So given length of string is longer than your required length. That means our case of this involute is of a longer string. So very easy, let us start the example. So first of all, we will draw this circle. Now we have the diameter of circle is 40 mm. That means we will draw the circle with 20 mm as a radius. So we have drawn this circle first. After that, we have to draw this straight line, which is indicating the string length. So as I have said, you have to first draw the larger length of these two, longer length of these two. So 150 and 125.66. Which is the longer length? 150 mm obviously. So you have to simply draw this line of 150 mm like this. And after drawing this line, you have to just indicate the point pi d distance away from this line here. So you will indicate this point pi d distance away on this line like this. So here, as I have indicated by this red point, you have to indicate that point on your sheet. So first of all, you will draw the total distance of 150, and on the same line, you will indicate the distance of pi d, which is 125.66 like this. I have indicated like red point. After that, we have to give numbering to this circle. So here we have divided this circle into 12 number of equal parts. Let us give numbering. So the starting point of connection of the string with circle would be 0 point, and as we know that we are using winding operation, that means our string would rotate in anti-clockwise direction, and the first portion of string during your winding operation will get in contact with this portion part 1. That means this will be the first point of contact of this string when we start our winding operation. That means this point would be our initial point 1. So this is your 0, this is your 1. That means your point 2 is here. 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. After that, we have to divide this line also into 12 number of equal parts. Once again, you will have one confusion. Don't worry. Always remember, you have to divide the pi d length of line or your circumferential length of line into equal number of parts of that of circle. So here, this is your pi d length. So that means this is your complete pi d length. You will be dividing this pi d length into same parts that of the circle. So we have divided this circle into 12 number of equal parts. That suggests that we have to divide this straight line of pi d length into 12 number of equal parts. So now let us start with 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now let us observe. After this 12 point, we are having remaining string like this. So we have to indicate additional parts on this string. Why? Because it will denote our endpoint P of your string. So we must denote this endpoint P of the string. So now for that, we already denoted this point P of the string, but we want to know that this point P is at which part we are getting. So for that, what we'll do is, so before getting into that, let us understand one more concept, one novel concept. So in that, you take out your rounder first. Okay, after taking out your rounder, take the dimension of 0 till 1 on this straight line, 0 till 1 on your straight line. Have you taken 0 till 1 on your straight line? Okay. Now, after getting your dimension of 0 to 1 on your straight line, put your rounder at 0 point on the circle and try to make arc on this circle like this. Then you will get to know that the dimension of 0 till 1 on the straight line is exactly the dimension of 0 to 1 on your circle. and it is obvious that both the dimension must be equal. Why? Because we have here divided the pi d length into 12 number of equal parts, and which is the same pi d circumferential length of the circle, which we have divided into 12 parts. So the both distances are same. The straight line is also pi d length, and the circumferential circle is also of the pi d length. That means 0 till 1 on your straight line is exactly equal to 0 till 1 on your circle. So that means what we'll do is, we'll once again take the dimension of 0 till 1 and we'll try to reproduce the dimension of 12 and ahead. So put your rounder at 12 and try to reproduce the dimension from 0 till 1. So you have taken 0 till 1 on your rounder, put your rounder at point number 12 and try to cut this line to get additional dimension on this line. So we have got this point number 13. From point number 13, try to draw this portion, you will have point number 14. But as you can see, our 150 distance is here in between your 13 and 14. So this will be your point number P. So as you can see, your point P is just little bit more than your point number 13, as you can see. So which suggests that your point P is closer to your point number 13. That means our curve would end near to the point number 13. So now once again, we have taken the dimension of 0 till 1 and we try to reproduce the dimension of this string after this 12. So we have taken 0 till 1 because each of the dimension are equal. 1 to 2 is equal, 2 to 3 is equal. So we have taken any dimension 0 till 1. You have put your rounder at point number 12 to reproduce dimension on the same line. After this 12, you have cut this line. So we have this 13. From 13, you have to cut this line. You will be having this point number 14. Now, as you can see, our 150 dimension ends somewhere here. This is your point P. Now you can see that point P is closer to your point number 13. You can see this is your point number 13 and this is your point P. So it is closer to your point number 13. So now let us denote these new points on this circle. So we know that we have 12 number point here. So for denoting this point number 13, what we'll do is, you have to take the dimension of 12 till 13 on your rounder. Put your rounder at point number 12 and try to cut this line here. Then you will be having 13 just adjacent to your 1 number point or overlapping this 1 number point. So 1 and 13 would be the same point. And this additional point, you have to take the dimension of 13 till point P and you have to put this rounder here at 13 point, or you can say 1 point, and you will try to cut this point here. Then you will be having this final point as your P point. Not P13, but this will be your final point, P point. So once again, what you have done is, you have to take the rounder 12 to 13 on your straight line and we're trying to generate 13 point on a circle now. So we'll put our rounder at 12 number point and we'll try to cut this line. So it will cut exactly at point number 1. So that means point 1 and 13 would be the same point. And after that, you have to take the dimension of this 13 till this remaining point P distance, which is the smallest distance. You have to put this 13 or point 1 and you have to cut this line. So you will be having this point, which will be your final point, point number P on this circle. Not P13, but this will be your point P. After getting this point, it is simple. You have to simply draw tangents from each and every point, from 1, from 2, from 3, from 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13, which is already drawn from your point number 1. After that, simple, at the first process, the portion of 0 till 1 will overlap over the circle on 0 till 1. So you will be having remaining string starting from 1 till P. Remember, 1 till P. So you have to set on your rounder 1 till P. Don't take 1 till 14 or don't try to take 1 till 13. It is a big mistake you will commit in examination. And obviously, most of the time students are doing the same mistakes. So once again, take the dimension from 0 till point P, which is just ahead of point number 13. So this is your point P, which is just ahead of your 13, which is 150 mm point. So you have to take the dimension of 1 till P, and after getting this dimension, put your round at 1 and try to get this point P1. Now take the dimension 2 till P. Put your rounder at point number 2 and try to get this point P2, which is 2 till P distance. Now put your rounder at 3 and try to take the dimension of 3 till P and put your rounder here to get this 3. Now put your rounder 4 till P, put your rounder 4 on the circle and try to find out this point P4. Now take the dimension of 5 till P on the straight line and try to get this point 5 from point 6, try to get this point 6. 7 till P, try to get this point 7 till P. 8 till P on your rounder and try to get 8 till P, that means point P8. 9 till P, so you will be having from 9 till P9, likewise P10, P11. Now from point 12, so you have to take the dimension of 12 till point T. So you have to take 12 till T, so you will be having this point, which is nothing but your P12. Now from 13, also you are having one smallest distance, very small distance, you have to take 13 till P, and you have to 13 means your point number 1 itself, because your 13 and point 1 would overlap each other, which is the same point. So from this point, you'll be taking distance of 13 till P, which is smallest distance. If you try to cut 13 till P, you will be having this final point, which is nothing but your point P. Now, after getting all these points P, P1, P2, P3, P4, you have to just simply connect these points to get your curve generated. So very easy, you have to just practice 2 or 3 times and you will master this example. Let's see one more example. Problem 3. An inelastic string is unwound to a length of 120 mm from a drum of diameter 30 mm. Draw the locus of the free end of string, which is held tight during unwinding. So here we are dealing with unwinding operations. So the example is same. Here we have to trace the locus of free end of the string, which is held tight during the unwinding. So locus of free end of the string, that means involute we have to trace. We are having string length, which is 120 mm, and the diameter of drum, or you can say circular diameter, is 30 mm. But here the word is unwound to a length. Unwound means we are unwinding the string. We are opening the string from the circle. So our assumption will change here. So here unwinding of the string is done. As an assumption, length of the string would be greater than your circumferential length or your 2 pi r. That means this is once again our longest string example, but in a different manner because we are unwinding the string. So let us first start with the calculation of required length of string. So required length of string is equal to pi d, pi into 30, which is actually the diameter of the drum, which is exactly equal to 94.25 mm. Here the given length is given, as you can see, 120 mm. So the given length of string is 120 mm. Now we are having two lengths, 120 mm, 94.25. So you have to simply compare these two lengths. So we are comparing these two lengths, and it is obvious that 120 is greater than 94.25. That means given length of string is longer than the required length. And obviously we are dealing with the longer string example. So our given length of string is longer than required length. So now let us start the example. So first of all, we have to draw this circle with the given diameter. So your diameter is 30 mm. That means 15 mm as a radius. You have to draw one circle. After drawing this circle, we have to draw the string length. So here let us compare. These are two string lengths. So we get confusion, sir. Which string length should we draw? So always remember, you will draw the longest string length first, which is 120 mm. So you'll be drawing 120 mm string length first. So we have drawn in this case string length on the topmost portion of your circle. You can also draw from the bottommost portion like our previous example. For this example, we have drawn this on the topmost portion of the circle. So you have to draw one tangent line of 120 mm. And on the same line, you have to indicate this another dimension of 94.25. So on the same line, you have to indicate this point 94.25, which is nothing but your point P8, or you can denote it by this red point, or you in your drawing sheet, you have to denote it by a dark point, little bit dark point. So you can get to know that this is your extra string and this is your pi d length. After that, next thing is we have to give numbering. So in the previous cases, we are dealing with the winding operation. That means we try to wind the string over this circle and the string gets in contact with this portion first. But in this case, let us understand we are unwinding the string. That means string is already wound around the circle. So we have to start unwinding or detaching the string from your circle now. So this is the starting point. So this is always the point 0, or you can say P0 point. Your string's end point is here on the circle now. So if we try to unwind the string, then it will get unwinded in the left hand side direction like this. So let us suppose this is point 1. So we are unwinding the string of portion 0 to 1 on this anti-clockwise direction. So first string would get unwound around this point 1. So that means this portion would be now your point number 1. Once again, this is your 0 point, and we try to open this string in the anti-clockwise direction like this. So string will open around this point 1 or the first part. So string will open around whichever the part in the first position. It is nothing but your point number 1 on your circle. So this is your point 1, because we have opened this string in anti-clockwise direction. That means your string will get open around this point first. That means this is your point 1. After that, this is 0 1. So it is obvious that 2 3 4 5 6 7 8. So we have divided this circle and we have given the 8 number of parts. After that, simple, you have to divide this line into also some equal number of equal parts. So it is obvious that we will be dividing this pi d length of line, which is this length till this red point. So this is the pi d length of the line. So we will be dividing this length into 8 number of equal parts: 0 1 2 3 4 5 6 7 8. Why? Because our circumferential distance of the circle is divided into 8 parts. That means our circumferential distance of this line is also divided into 8 parts up till your point P8. Now you can see on your drawing sheet you are remaining with this extra string, and it is obvious that we are having a longer string. That means we are having this extra string. So now for this extra string, we need the numbers on this string. So that means we have to reproduce the dimensioning number on this string also. So for that, what we'll do is we'll take on our rounder 0 till 1 distance on our rounder. 0 till 1 distance you have to take on your rounder. Have you taken the distance 0 till 1? Okay. Now after that, taking the distance, you have to put your rounder at point 8, and you have to just reproduce the dimension on the right hand side once. Once you will have point number 9. On the right hand side twice you will be having point number 10, and you will try to get thrice the dimension, but your point would be far ahead of your 120 line. So you need not to draw that point outer side of your 120. You have to just stop at point number 10, and whichever the portion, smaller portion left after point number 10, you just simply write down that point as 11. So once again, what we have done is 0 till 1 you have to set on your rounder. You have to put your rounder at 8. You have to reproduce 9 and 10, and after 10 you can't reproduce the dimension once again. So you have to stop there at point number 10, and whichever the smallest distance remains, you have to just write down 11, which is the last point of your 120 mm line. After that, we are having these additional points on this line. That means we have to just simply locate all the points of this line onto this circle also. So how to locate these points? So you have to simply take the dimension of 8 till 9 on your rounder, put your dimension of 8 till 9 on your rounder, put your rounder at point 8, and you have to go in rightward direction because this is a dimensional pattern. So 4, 5, 6, 7, 8, that means 9 dimension must be on the anti-clockwise side. So you have to take the dimension of 8 till 9 on your rounder, put at point number 8 your rounder, and try to cut circle somewhere here. So you will be having point 1 and 9 at the same place. So this will be your point as 1 as well as your point 9. From point number 9, take the dimension of 9 till 10 and put your rounder at point number 9 and try to cut this line somewhere here. So you will be having 2 and 10 at the same point. After point 10, you will be having smallest distance between 10 and 11. Take on your rounder, put your rounder at 10 and try to cut this circle somewhere here. You will be having this point 11, which is the smallest distance away from your point 10. and write down this point as 11. After identifying all these points, the next step is very easy. You simply draw tangents from each and every point. So from 1 point, draw tangent. From 2, draw tangent. From 3, draw tangent. From 4, draw tangent. 5, draw tangent. 6, draw tangent. 7, draw tangent. 8, draw tangent. Now you will ask, sir, how long tangent should be? So there is no fixed length. You just draw it arbitrarily. If you practice more of the examples, you will obviously get to know which is the approximate length you should draw for each of the case. So now you have to draw tangents arbitrarily. If you are having extra length, then you can rub it afterwards. So now let us do the next step. So in this case, we are unwinding the string, means we will open up the string from this circle. So first of all, we try to unwind the string of this 1 till 0 portion. So this is the string length 1 till 0 portion. So on this horizontal string, we are having the dimension of 0 till 1. So take on your rounder 0 till 1 on your rounder. Now put your rounder at point number 1 and try to cut this one tangent line somewhere here. So it will denote your total dimension open string 1 0. Now when we try to open the string from your point 2, so it will open up the string from your point 0 till 1 till 2. So it will open up the complete string from 0 till 2. That means the length dimension of this 0 till 2 would be on this straight line. So put your rounder at 0 till 2, take the dimension of 0 till 2 on your rounder. Put your rounder at point number 2 and try to cut this line. So you will be having total string open from this circle from your 2 till 0. So we will be having this point P2. Now at point number 3, you will have total 3 portion of string open, 0 till 1, 1 till 2 and 2 till 3. So you will be having total string length open from the circle is 0 till 3. So you have to take from your rounder 0 till 3 dimension of your string. You have to move to point 3 on your circle and try to cut this line. So it will denote your point P3. Now for P4, the string now open would be from 0 till 1, 1 till 2, 2 till 3 and 3 till 4. So we will be having total open string length starting from 0 till 4, half of the circle. So now we have to take the dimension from this string 0 till 4 from this horizontal string. You have to cut from this point 4 on your circle to get this point P4. Now for P5, our total string would be open from 0 till 5. You will be having total length from 0 till 5 here. So you have to take dimension of 0 till 5 on your rounder. Put your rounder at point number 5 and you have to cut this point here. You will be having P5. Now our string will open from 0 till 6 on the circumference of circle. That means we have to take 0 till 6 on our rounder. Put your rounder at point number 6 and try to cut this line. You will be having P6. Now take the dimension of 0 till 7 on your rounder. Put your rounder at point number 7 and try to cut this line. You will be having P7. Now try to take the dimension of 0 till 8 on your rounder. Go to point number 8 on your circle and try to cut this line. You will be having this point as point P8. Now for point number 9, you have to take 0 till 9 on your rounder. Put your rounder at point number 9, or you can say point number 1 because both are the same point. So you have to cut this line. You will be having point P9 somewhere here. For point number 10, you have to take dimension from 0 till 10 on your rounder. Move to your point number 10, which is also a point number 2. So you have to cut this line. So you will be having this point 10 somewhere here. And for point number 11, which is the last point, so you have to take the dimension of 0 till 11 on your rounder. You have to move to a point 11 and you have to just mark the dimension here and you will be having total dimension of 120 mm. It is obvious that it is said that unwound to a length of 120 mm from a drum. So this is your drum and we have now unwounded the string of 120 mm around the drum. So this is the final position of your string. And this is the dark curve generated, which is nothing but your involute in this case. Now, let us see one more example. Problem 4. One end of an inelastic string thread 140 mm long is attached to circumference of a circle or circular disc of 40 mm diameter. Draw the path of the free end of the thread. If it is completely wound round the disc, keeping the thread always tight, name the curve. So here once again, we are drawing the path of free end of the thread. So whenever you hear or you can see the word path of the free end of the thread or a path of a free end of a string, then it is nothing but your involute. In this case, you have to draw just the involute. So here our involute thread length is given as, string thread is given as 140 mm long, which is a given length of the string, and which is we have to wound round the circular disc of 40 mm. That means this is the diameter of the circular disc. We are having two data. Before moving ahead, we must assume certain data. So here binding of string, we are assuming length of the string is greater than 2 pi r, or the circumferential distance of a circle, and this is obviously a longer string case. So let us start first calculation. Required length of string is exactly equal to pi d, where pi into d is 40 mm. So we'll be having 125.66 mm. Now given string length is obviously given as 140 mm from your example. So 140 mm. So we are having two different lengths. So whenever we are having two different lengths, we have to just compare these two different lengths. So as we can see, 140 is obviously larger than 125 as compared to 125. So hence, given length of string is longer than the required length. So this is obviously the example of a longer length. So now let us start the example. So for example, we'll start with first this circle. So you have to draw this circle with 40 mm as a diameter. 540 means diameter is 40 mm. After drawing this circle, you have to draw one straight line. Now once again, there should not be any confusion. You will be drawing first 140 mm, which is the larger length, and then after you have to indicate 125.66 mm on that line. So I have drawn one horizontal line of 140 mm, and on this line I have indicated this pi d distance 125.66 by this 12 number of points. Now after that we will give numbering to this circle. So here in this case, this is a winding operation. That means this string will rotate on anti-clockwise direction, and the portion of this string will first get in contact with this portion. So that means this will be your point number 1. This is 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Once again, when we try to wind this string, the string will first get in contact with this circular point. That means this point is nothing but your point number 1, and then after you have to give the numbering. After giving numbering, we'll give numbering to this straight line, or we'll divide this straight line into same number of equal parts. So in this case, we have divided this circle into 12 number of equal parts. That means we'll be dividing this straight line also into 12 number of equal parts. Once again, there should not be any confusion. We have to divide pi d length into 12 number of equal parts, because pi d length is exact length of this circumference of the circle. So we'll be dividing this circumference of the circle pi d length into 12 parts. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now as you can see, you will left with this additional string, and it is obvious that it is example of longer string. That means you will be having this extra string. For that, it is simple. You have to take on your rounder 0 till 1 distance and try to reproduce the dimension ahead of 12. So we will try to reproduce the dimension ahead of 12. We'll be having point number 13, and ahead of point number 13 we can't reproduce any 14 number point. So just beside this point number 13, you will be having your final point, which is 140 mm away. So denote this point as P0. So what we have done is we have taken 0 till 1 on our rounder. We have to put our rounder at 12, and you will find out point 13. And after point 13 also, there will be very smallest fraction of line would be left. So you have to indicate that final point as P0 point, which is a starting point. After that, simple, you have to draw this portion of 12 till 13 on your circle. So you have to take the dimension of on your rounder 12 till 13. After adjusting 12 till 13, you have to put your rounder at 12, and you have to try to cut this circle. So the 13 and point 1 would be at the same place. So your point 1 is also your point 13. After that, simple, you have to draw tangents from each and every point. So from 1 tangent to tangent, from 3 tangent, from 0.4 tangent, from 5 tangent, 6 tangent, from 7 tangent, 8 tangent, 9 tangent, 10, 11, 12. Each of the portion you have to draw the tangents. After that, this is a binding operation. That means this first portion of 0 till 1 will overlap this circle, and we will be having remaining portion from 1 till point P0. So on your rounder will adjust 1 till P0. You have to put your rounder at point 1 on the circle, and you will try to cut this line to get this point P1. Now take the distance from 2 till P0. Put your rounder at point 2 on your circle and try to cut this line somewhere here to get P2. Now take 3 till P0 and put your rounder at 3 and try to cut this line. You will have P3. Now point 4 till P0. Find out point 4 till P0. So you will be having this point P4. Now 5 till P0, from 5 you will be having P5. Similarly 6 P0 you will be having P6. You have to take the dimension of 7 P0, you will be having P7, 8 P0 P8, 9 P0 you will be having P9, P10, P11. Now you have to take the dimension of 11 till P0. From your 11 points you will be having this point as P11, 11 till P0. Now you have to take the dimension of 12 till P0. So from point 12 you have to find out this point on this line. So you will be having this point. So you have to adjust 12 till P0 on your rounder. You have to put your rounder at point 12 and you will be having this as a final point. And it is obvious that 13 P0. So 13 P0 means 13 you have to go and you have to find out this point, that this will be your point on the circle. So this will be your final point. So after getting all these points, you have to simply connect these points starting from P0, P0, P1, P2, P3, P4, P5, P6, 7, P8, 9, 10, 11, 12, 13 and P0 on the circle. So these are the points, nothing but indicate your involute of a circle for winding operation of a longer string. This is all from my side. If you enjoyed my lecture, then do not forget to like and subscribe to show your love and support. Keep learning, stay connected. Bye-bye.